All right, so we go from Azure to GCP. So Forward Cloud Tech is truly a multi-cloud conference. But first we want to thank one of our sponsors, Bucket AV. So Bucket AV provides antivirus protection for Amazon S3 and Cloudflare R2. You can scan your buckets for viruses, worms, Trojans. Bucket AV detects malware in real time, periodically, on access or on demand. And more importantly, your data never leaves your AWS account. So we have, I'm old. Service agents for the search for transitive access in GCP with Kat Traxler. All yours.
Thank you, Chris. Thanks everybody for coming. And hello, team. Yes, my name is Kat Traxler. I'm a security researcher, and I do my own graphics. I mention this because as we go through this presentation, you're either going to have the thought of like, wow, she does her own graphics, or like, she totally does her own graphics. Yeah, she needs a team. Okay. Yeah, that was the about me. Okay. Today is going to be the first time I'll be speaking publicly about a new transitive access vulnerability in Google Cloud. Specifically, the ability to move and exfiltrate data out of Google Cloud storage buckets without storage permissions. Isn't that cool? But first, we're going to do this like classic story arc setup that I hope is going to feel very cozy and comfortable for everybody. This classic trifecta of we're going to build you up, build your knowledge of service agents. What are service agents? I'm assuming that most people are coming from an AWS world, so I'm going to try to do a lot of callbacks to AWS and help people like make those connections. We're going to build up your knowledge on service agents. Then we're going to do some threat modeling about like what could go wrong with service agents. And honestly, I think the cooler part on service agents is what can't go wrong. And then finally, the payoff is like what did go wrong demonstratively. And then a little like what can you do about it? Spoiler alert, not a ton. Service agents fall into this category of machine identity, as opposed to human identities, user identities. This is like machine identities. And across all of the clouds, whether you're working in AWS, Azure, or Google, they're going to fall into two different categories. The first category is the customer managed. And managed is going to mean a little bit different in every cloud, but there are some through lines to it. So you have your AWS roles, GCP service accounts, and your Azure user-assigned managed identities. Across all three clouds, they serve a very similar purpose. They're your backing identities for code executing on a IaaS instance. Anywhere where you have a high degree of control over the inputs and the outputs and the execution of some either IaaS, PaaS, even SaaS, you're going to have to supply a customer-managed machine identity. This talk is not about customer-managed machine identities. We're squarely in the realm of the CSP-managed machine identities. These are your AWS service-linked roles, your GCP service agents, and your Azure system-assigned managed identities. These are used as backing identities for your predefined tasks. Think writing logs to a bucket, scaling infrastructure, those background tasks in the cloud that have very little end user input, where it's going to be an automated task where you don't necessarily control where things are written to or the exact text of it. And in Google Cloud, those machine identities are called service accounts. They are resource types like any other resource type in Google Cloud. They live in a project and then live in that resource hierarchy. And like all other clouds, they're broken into two different types. That first is those customer managed ones, those resources that you're going to create in your project. You have control over the life cycle, and TLDR, you are in charge of securing them. And then there's the other half of the spectrum, the Google managed service accounts. What defines those is that they live in, surprise, surprise, Google-owned projects, and they are in charge of securing them. They are resources in their hierarchy. And if I were to make some assumptions, I'm going to assume that Google has thousands upon thousands of Google managed service accounts. Service accounts to support their consumer infrastructure, to support internal processes, but only a small segment of those Google managed service accounts are really considered service agents. There's actually 87 possible service agents that could be created in relationship to any given consumer project. Fun fact. So how do you get one of these little service agent friendly fellas to show up? And I do anthropomorphize service agents as these little friendly bobble guys. How do you get them to show up? You generally have to enable a service. So unlike AWS, where everything is just on and you use it and go to town, in Google world, you have to specifically enable services. So step one, a user enables a service with a service usage permission. In response to that, a service account is created in a Google-owned project. Now, if this is all that ever happened was service enablement and then service account creation, we would never know about these guys because we don't have visibility into a Google-owned project. But as it happens, a role is assigned in our consumer project to that service account, typically a service agent role. And we can see that from the logs, it's this kind of all-powerful service agent manager that assigns these roles to a service agent. So with this architecture, with this one-to-one architecture, you have created the P4SA. I'm going to do my best to call them service agents through this talk, but you might find me slipping and calling them P4SAs, because that's the Google internal name for them. Per product, per project. And this is where the architecture really differentiates from service-linked rules, is that one of these little service agent guys is created for every service that's enabled for every project. There is a one-to-one relationship there. P4SA. So what not to freak out about? I think when people from the AWS world first learn about impersonation, like that's the first thing people kind of freak out about when they hear about service accounts. And that falls under the realm of spoofing threats. And typically, we don't consider spoofing threats when we think about service agents, because service agents are resources living in Google managed projects. It's Google's responsibility to secure them. And so since these spoofing threats require IAM permissions, it's clearly under the on the other side of the cloud responsibility moat, shall we say. We could argue on whether or not Google's good at securing their projects, but it's clearly outside of the scope of the threats we're going to consider. But now for what can absolutely go wrong. We might not be able to set IAM permissions on a service account. We might not be able to generate an access token for a service agent. These service accounts living in a Google-owned project. But I ask on whether or not attackers are playing a CTF and whether or not they really care if they can generate an access token. I'll ask all of our threat intel folks if that's an attacker's goal to generate a access token, and certainly not. It's their intention to use those permissions for fun and profit. So what you're going to see with the document AI service is just one way to use the permissions of its service agent. Not generate an access token for it, not impersonate it per se, but to use the built-in functionality of the service to take advantage of those mechanisms to kind of go with the flow, as it were, to use some of the functionality to leverage the agent. And as it turns out in this one particular service, when you combine its functionality with some privilege permissions that are automatically assigned to it, you have this perfect storm for privilege escalation. Right, so a little bit of documentation, that's a good graphic. A little bit of background on document AI. You really just think of it as a ETL service. It's gonna pick up some text, it's gonna do some transformation, and then it's gonna blop it somewhere that you tell it to. That transformation is really, for our purposes, null and void. We don't care. It's moving shit around. Interestingly enough, there's a couple different modes. There's a regular online mode, and there's a batch mode. When in batch mode, instead of doing these transformations, picking up text and plopping it over here, when doing these batch modes, instead of using the identity of the caller, it's going to use the identity of its service agent, right? So because of this just little characteristic, honestly, of the service, it creates this ability for somebody to leverage the service for evil. Let me switch over to the demo real quick, and I'm going to walk you through how to use the functionality of this service to move storage objects out of a project from one bucket to another. The demo is going to showcase it moving objects from one bucket to another in the same project, but there's no reason why you can't move it to another project. Let's see here. Oh, that worked. Okay. So I have two workflows created. One that's leveraging just the regular process API. I think I mentioned this one's doing things right. This one's leveraging the identity of the caller. And so what we care about is that the identity of the caller has permissions to grab the text and move it. So I ran this earlier. As you can see, the caller doesn't have permissions to get the object. The caller only has document AI permissions. So it's going to fail. Oh, it's not flipping over. Interesting. Well, let me see here. Maybe we have to go to the video.
Something just a moment ago to get it.
Did it? Let's see here. There we go. Oh, yeah. Okay, it's the whole other screen. Okay. Let's see where we go here. Oh, there's a delay. Oh, that's awful.
No, it's the video.
Oh, is it on the video?
Yeah.
Oh, okay. Interesting. So in this case, we're running the workflow. we're looking at the input and the output bucket, and we're going to run that as a service account that only has document AI permissions. And we're going to tell document AI, grab some input from one bucket, do some processing. In this case, it's going to really do nothing. And then plop it in this destination location. When we run it, it actually is going to run it as the service agent. That's the interesting part. And it's my belief that hundreds of people probably looked at this, but until you understand that the sensitive actions that were performed are not being performed as the caller, but on behalf of the caller, and in AWS world without that pass role permission, in Google world without act as, you realize that you have a abuse potential. As you imagine, reporting this to Google was smooth sailing. They completely understood the issue. They've remediated it, and all is well. No, that is my third joke today. Absolutely not. No, the takeaway is that this issue with document AI is still vulnerable. There's a repository on my GitHub that you can download and run these Terraform modules to demonstrate the moving of storage objects without storage permissions. As a cloud customer, you don't have to be using the document AI service to be vulnerable. That's a really important takeaway. A lot of these feature abuse cases are like that, where you only have to have the ability to enable the service. Only the possibility of it to exist means that you're vulnerable. So if you're not leveraging a couple org policy constraints to prevent the enablement of this service, this can be enabled by an attacker with the permissions to enable services and then leverage to move documents. There's been some back and forth between myself and the Google VRP on whether or not this was work intended as expected, whether or not this was fixed. One of the reasons why I really love working with Google is that, like me, they're a little messy. We've had some messy back and forth. The takeaway is that they initially closed it and did not award a bounty for it, but surprisingly last week they changed their mind, reversed the decision, and I was awarded a bounty for it. So that was nice. Thank you guys. Appreciate you. If you want to read like a more comprehensive, verbose description of this vulnerability, the risk to your organization and how it's discovered, QR code up above. Now my soapbox slide. Everybody's got to have a soapbox slide. Like, what does this mean, and how do I internalize this, and how I internalize this issue and a lot of issues that I work on is that I am least privileged was never the path to a fully secure cloud. At times it can feel Pollyannish. At times it can feel like we're on a hamster wheel, and it can feel like a distraction from more meaningful approaches like IAM blast segmentation and data controls. So remember, if you have your sensitive data segmented and you have the APIs tightly restricted, you'd never be impacted by this issue. And finally, kind of more on this transitive access issue. It's clearly nothing new. Since the dawn of time, the cloud provider documentation will always tell you that if you enable one permission, it will have X result. If you enable the document AI permission for batch processing on a processor, people will be able to process. A plus B equals C. It's a simple formula. But in the cloud security community, we've known about transitive access issues and the explosion of permissions since we started working on cloud. You can think of this as a very similar issue to the ability to generate an access key for another user. Just that act of being able to generate an access key for another issue multiplies from A to B equals C to A to B equals D and E and F, right? So this issue with the document AI service agent might be the first transitive access issue with service agents, but highly likely to be the last. And with that, I will take questions and let you soak in kind of my zeitgeist.
All right, do we have any questions in the room? Paul?
Paul.
Yeah, hi, Kat. So firstly, thank you for the talk. That was interesting. Yeah, I guess, so more generally, with Google Cloud Service Agents, do most of the, or all of the other agents, as far as you're aware, check that the permissions of the calling user are appropriate for the actions that they're going to undertake?
There's never a check. So I'll just put it that way. There's never a check to say, if a service agent's being used for some background task, there's never a situation where I say, well, let me just check the caller to see if the caller, no, that never happens. What happens is that they rely on the task that's being performed to not have a high degree of risk, right? So to be relatively narrowly defined. So kind of the methodology that you could take to finding more of these is to cross-reference the permissions assigned, auto-assigned, I will say, to all of these service agents, cross-reference those permissions with service functionality, and to come up with more bugs.
Any other questions? Oh, why do I keep walking back?
Thank you. We just crossed the 10,000 permissions bar on GCP. Did you ask Google to give a list of permissions that service agents get?
I'm sorry, can you repeat the question? You just got a 10,000 bounty? What?
On GCP, for when you grant the role service agent, this role contains permissions. Did you get a list of these permissions for each service account permissions that exist? Yeah,
absolutely. You can do this yourself to list out all the permissions that are assigned to service agents when you create them. I highly encourage everybody to make said spreadsheet. Yeah.
And then how quickly will that spreadsheet be out of date?
It already is.
So I had a question.
Yeah.
Any confused deputy kind of threats here that we should be thinking about? Or?
Not in the same way that you would think of in AWS because of the architecture. I get this question a lot from AWS-minded folks because of the architecture where it's the per product, per project. It's not a global identity where it could go cross-tenant. And perhaps this is why they don't use their equivalent of pass role when AWS does. You'll see AWS enforce pass role when you're attaching service linked roles quite a bit. You won't find that in GCP, and I'm guessing there may have been, and this is 100% a guess, there may have been some arguments around the architecture and not needing it.
Got it. One last question.
Hello, and thanks for the presentation. It was great. Just have a question. What led you to find this? How did you get to find this? Because it's interesting. We perform threat modeling. That's why I'm asking, like, how did you get here?
Yeah.
And then it's related to a question, right? There is a list of predefined, I believe, roles or permissions. Are they not bounded by any policy or anything? They just have full access, like the access that is predefined. Like, is there anything like monitoring or anything we can put on top of these roles, or it's just fully managed by this cloud provider?
Yeah. How I found it is I used to do a fair amount of like formal threat modeling with a company, and this was done through some formal threat modeling. So honestly, finding bugs often is a lot of slow and painful work until you can kind of catch that glint of this is not right. So that's how it's identified. And then, yes, I mean, the service agents are assigned extraordinarily, admin level permissions automatically. And I think the argument is that the resources that live in Google Project, impersonations off the table, they are, quote unquote, safe. I have a threat modeling article on my personal blog on service agents that can kind of give you a little bit more holistic look about how you can think about them. But I'm imagining a good argument was made saying, there's all of these threats off the table, make them project owner, who cares, kind of a thing. But there are actually some risks that need to be considered, especially when you couple that with kind of unbounded service functionality.
Cool. All right. Well, thank you, Kat.